But we have to think alternative, make some understanding of this particular field and particular subjects. So we have discussed that series of lectures on the computational linguistics. So as a discussion as a result of or introduction by series. And today the second and our speaker, Dr. Kishorjit is now with us, and he will be talking on bridging the gap language and computation. It's a very important and very interesting issue. Over to you, Dr. Kishorjit, please.
Yeah, thank you, Wazirin, and thank you to Dr. Monaldo for inviting me in this series. And it's a great pleasure for me to be in your series, so that I can share a little bit of my knowledge to participating here. To start with it, I don't want to stress much on the computational point of view, but I'll try to give you the basic concepts so that those people who are having the basic background of language can cope up with the concept of computation. So that is my objective, because if I go there on how the computing is going on, it may not be interesting for those people who are very new in this subject. Start with the presentation so that we can have a discussion on it at the later stage. Okay. Can you see my screen?
Yes, please.
Yes. Okay, fine. So this is my topic where I will try to bridge. I will try to just convey the message. What is there between language and computation. I'll try to demonstrate where it should start and where it should aim. Maybe the real part of bridging the gap, where normal people will be talking about computation and maybe left off, but at the end of this talk, you will be able to understand what is talk about computation. That is my target. So let's talk about the theme of this talk. So we have natural language which everyone talk. Say for example, we have your own language which you try to communicate among yourself. That is maybe Assamese, maybe Manipuri, maybe Hindi, whatever it be. That is the natural language which you try to communicate with other people. Now, on the other side, you have the concept of computation, where in the computation, what you require is otherwise the programming codes. So the two sides of the coin is one side you have people talking their normal language or the natural language. The other side, technically, there is concept. We'll try to put a hole on that coin so that we can communicate between each side, which is not left like that. It's different side of the coin. We'll try to just change the statement that there is a bridge or there is a hole in between these two sides of the coin. That is a concept. So at the most, what for example, because your language which you are talking about becomes the program code. That is what you may think about out of your box. Because every time when someone talk about computation, people started assuming that, we need to learn the programming language, we need to learn the programming code. But in future, there may be a time or there may be a circumstance where you don't need to go for the computation, you don't need to go for the programming. What you need to do is just say, so once this computer developed understand, you try to reason that so the internet is become almost programmable. That is the future. Change the technology. Because for computational linguistics and natural language processing. At the beginning, there was a little bit of difference between the two because computational linguistics are those computational approach is slightly changed and started working on the concept of the computation or the programming concept or the basic of computation. And to us, or otherwise the computer science people, we call it as natural language processing. That is the concept. That is the difference. Now, if you look at the, picture of this natural language processing, or in your term, you may call it as computational linguistic at the present context. So, what we require is we require three things. We require the language which you want to talk. You require the problem or otherwise the target which you want, okay, and then the another one will be something what you call as the algorithm. So what happens is you need a language, you need to have a problem is what something what we call as a target, and then you have to have an algorithm. Algorithms are generally designed by the experts. So these three are the basic parameters which is required when you start talking about the natural language processing. After all, the concept of all these three can be started from two, three, maybe a vision one, or vision one in sense like maybe it was something, or otherwise you can have another one through sound, or otherwise through speech. So the input or the starting point is through vision, otherwise through speech. They communicated through vision, and the speech. Speech is through sound. By through vision, you'll have in written form something, or otherwise in text form, or otherwise in image form, which will be converted by the optical character recognition. So this is the three important thing, and the input as speech and vision. So this is the starting point. Now, if we have to have an approach about all these algorithms and targets or something like that, what do we need to know, or otherwise what is the beginning or the starting point? So that is what I just want to convey. What to say, elaborate here, because the most important thing in life is the probability, because we try to assume it and we try to find the possibilities. Because of these possibilities and assumption, we start learning. So probability is one of the most important thing in mathematics, which just give people to learn, or people to just start assumption. So let's talk about the probability first, so that we can just come up with the real concept of the difference. Because if we talk about all this,
Dr.
yeah,
Kishorjit,
yeah.
sorry to interrupt, your slides are moving.
Oh, is it like that?
Yeah.
Okay. I think then there is some problem there.
Yeah, it's
Okay.
okay now.
Yeah,
It's okay.
let me just make it from here itself. That will be good.
Okay.
Otherwise, it's not
Okay.
changing. Okay.
because like making into full size, sometimes it's not moving. Anyway, sir, is it visible now, sir?
Yes.
Is it visible?
Yes, 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 it's visible.
And is it changing some all the slides?
Yes, yes, yes.
Okay, fine. So I was talking about here. Wow. Then you need an algorithm, and we need an algorithm. So this is what I was talking about. And then the input concepts will be through speech and vision, so that we can process the whole scenario of the natural language processing. The language, which means it's not a program, it's not a programming language, it's the natural language which we are speaking. So there it starts. So now the point is like how will be the target and what sort of algorithm we need to design. So that is the another point. So in order to start with all this algorithm designing part and all, we need to start, or we need to have the basic concepts of probability, because in mathematics I mean, if suppose we have gone through a little bit of mathematics, apply in our day-to-day life. Even though if we are not, even though if we are not learning mathematics, this probability is every time and everywhere. And we are not seeing like how it is in the real scenario or the real time events. But in reality, probability is very much there in each and every step of our life. Say, for example, learning of ABC in our state, in our early stage, is also another probability, because like we used to keep learning, because the event used to happen again and again. So when it keeps on happening again and again, we started learning the process of, we started the learning process, and thus we started learning the issue of the language. So that is the it's that, say for example, let's start talking about the probability. If you talk about the probability, we need to know about two terms called space and event. Space is something like where you will find all the possible outcomes, or all the possible things. Say for example, in a coin, if you want to toss a coin, there are two chances that it comes out as a head or it comes out as a tail. So there are two possibilities. So it's all the possibility coming. Counting all the possibilities. One, two, three, four, five, and six. So the whole possible six. It may become four, it may become five, or it may become six. Now, what about the even? Even is something, or otherwise is a subset of that sample total. If you have a total sample space, out of that, you're going to pick up particular subset which is of our importance, or otherwise which is important to us. Say for example, dice toss. Say for example, let A represent the event such that the outcome of the dice experience. Wait. Like it should be a multiple of. It should be like it should be divisible by 3. Okay, if suppose if it is divisible by 3, which means like out of this divisible by 3 is only 2, so that is one of the even. So of this the even, based on the even, the only possible things is 3 and 6. So that is the starting point. Again, we haven't calculated the probability yet, but the concept is the concept of even and sample space. The sample space started here. Now, what is a probability after all? It should be a non-negative number, because probability cannot be a negative value. And moreover, the probability should be less than equal to 0, and again it should not be greater than 1 also. So like probability should be between 0 and 1. So this is the limit of a probability. What we learn to perfection is 1. What we don't learn anything is 0. That is a simple logic. If you learn with perfection, the probability is 1. If we are not learning anything, that means the probability is 0. That is the concept. You need to find all the values whatever it be, if it tends to one, which means like you are almost come, I mean, you almost become to the perfection. That is the concept of probability. Now, how do you calculate probability? Say, for example, if you toss a coin, that means like there is 50-50 chance that it comes as head or it comes as tail. So whatever it is, the sample space is either head or tail. So that is the thing. Now, if you if a coin is fair, should assign equal probabilities to the two outcomes, that is head or tail. Now, but remember, all the outcome, if it is added, then it should come to one. The sum should come to one. That is the point. Okay, so what will be the probability of getting a head? It's 0.5. How? Because probability of getting a head will be head will be of all the sample space, you have only one head. So that is one. But what about the sample space? Total number of sample space is two, because you will be having either head or tail. So you have two here, there is one here. So 1 by 2 will be 0.5. Similar case for tail also. I mean, the total space is 2, because the output will be either head or tail. That means like there is two possible outcome. That is the point here. And what will be the possibility of getting a head is only one, because at a time there is only one chance of getting a head. What is the probability of getting a tail? You have only one chance, so you have 1 by 4, or 0.5. But remember, if you, sum up all the it should come to one. As I told you in the previous slide that the probability cannot exceed one. So perfection of anything will be one. And suppose if it tends to one, means like you are tending towards the perfection. That is the concept. So now, the full summary is here, where the number of outcomes corresponding to the event it should be the numerator, and the total number of outputs should be the denominator. So that is the definition of the probability. Say for example, if you look at the playing card, you'll have 13 playing card, each of all the different things like your spade, your all these things. Okay, so what is the probability of drawing a spade out of this 52 deck of card? So there are 13 number of card of with the symbol spade. So there is there are, so the numerator will be 13, and the total number of possible outcome is 52. So it is 52. So if you just make it simplify it, you will get 1 by 4, or otherwise 0.25. So that is the concept of the probability, and the basic concept of probability defines here. And I suppose some of you have already known the concept of probability now. At the end, the probability is nothing but the possibility or chances of getting something. That is the meaning of it. Now, what about, this is another example here. So you have two in the deck of 52 cards. So you'll have four number of, the number 2 in 4 different sets, in the spade, in the diamond, in the all those things. So if you have to find out the 2 of all, in all the 4 different symbols out of the 52 card, the probability is here. Probability of drawing a 2, which means like you will have 4 cards which will have 2 numbers. So 4 by 52 you will get 1 by 13, and otherwise you will get 0.77. Okay, so that is the thing. Now coming to NLP now. Where are you going to apply this? That is another question. Maybe you may be thinking about why I'm talking about probability. I'm talking about probability because everywhere when you talk about the computational linguistics, everywhere, leaving the rule base, if you move ahead, probability is everywhere. So, so if suppose, I mean, if you want to find out what is the chances of having a verb, having, when you pick up any word from the dictionary, any word from the lexicon, what is the probability of getting a verb? I mean, verb of all the lexicon which you have in the dictionary. It's very simple. You can find out the probability of it. Say, for example, you need to find the total number of verb. You need to find the total number of word in the lexicon. So total number of verb divided by total number of word in the lexicon will definitely give you the chance of having the verb from that very particular lexicon. So now, if you started thinking out of the box, then you maybe start. I mean, you maybe think. I mean, you start thinking about, right, will this apply again? Say, I suppose, if I write something like this, I leave a space over here, mango. Okay, so I leave a space over here. Can you imagine like what will be the what type of verb it will be here? Or otherwise, what will be the what will be the word here which can be mentioned here? I eat mango will be the most probable answer. Say for example, in the lexicon, I have some 1 lakh word. Okay, I cannot put here. Any one of it will not be fitting here. The only possibility is if I put a verb here, then that is the most, I mean, feasible one. So if I have some 10 or 5,000 verb words, so there is a chances of reducing from 1 lakh to 5,000 word, which means like there is only some 5,000 word which can fill up this space. So you come up to a very close, very close answer to this space. I mean, to this filling up the space. So you have some 5,000 words only now. Again, what will be the best of this 5,000 can again be calculated by having another probability. Like instead of doing verb, you can start talking like probability of, a verb which is followed from a particular subject. Okay, from a subject. Okay, subject that too particularly I. Okay, so if you find a probability which is followed by a verb from the particular subject I or a pronoun I. If suppose if you find these two combination, then again the number of probability or number of word which is reduced from 1,05,000 can again be marginalized to some 1 to 5 word or 5 verbs, and then at the end of that 5 verbs, one will be most. I mean, whichever have the highest probability will be able to hit here. So maybe like out of that 5 word, if you get something like drink is one verb, eat is one verb, and then run is one verb. Okay, then maybe something like write is one verb. Okay, write the RIT. Okay, write is one verb. Okay, read is one verb. Suppose there are few words. I mean, if you get few 5 verbs, then of this, I suppose the verb. I mean, the highest probability which we change towards one, then automatically you can just conclude that it will be the best probability which can be filled up in this particular space. So that is how the machine can be taught, or otherwise the probability can be implemented in the real sense of natural language processing or computing. That is one example, one simple example. So that, I mean, a very simple example which everyone can understand. Again, this is another thing. Well, yeah, I have explained about up to this, how to compare. Yeah, this is the simple example which I have explained. Now coming to the next concept or next type of language modeling. Say, for example, I was talking about I was talking of a particular word, or I mean having in a structural or otherwise in a sentence how to just come up with one particular word in a sentence. Now, what about having a very good number of words in a particular sentence? For example, if I have n number of words, n number of words. If I write I eat mango, okay. If I say if I eat mango, there are only three words. This is W1, this is W2, and this is W3. So I have only three words. What will happen if you have multiple words? And how will you identify the sequence of the word, or otherwise how you're going to check the sentence or the structural structure of that particular sentence? That also can be solved by what you call as probability. After all, probability is what we have learned it and what we have learned in all real time. How you're going to, the particular word, how, whether that particular word is suitable in that particular position, how you're going to find it out. That is the thing which is being explained here. I'll be elaborating more in the next slide. Don't need to worry. But the thing is, in this particular slide, I just want to just make you to a term called language modeling. Okay, or otherwise, in short, we call it as LM. Okay, the language modeling is something that computes the probability. Okay, so the model that computes the probability of some word or anything, or maybe any target, is what we call as language model. Okay, in the natural language, we call it as the grammar. Okay, and now if we started talking about all these things in the NLP or computational linguistics, we can just come up with a new term called language model. That is the thing. Now, computing the particular thing which I was talking about. Suppose if you want to talk about W1, W2, and all those things with WN probability of all these things, this is the one. This is an example. Because the whole thing, if suppose if you read that, the thing is like the other red line or maybe a green line in order to show you that your grammar, your sentence grammar is wrong. So how does this really work? Yes, of course, there are different methods of that. One of the simple method is what I'm going to discuss here. Say, for example, we'll try to come up with a concept of chain rule. Okay, I think you haven't come across it, maybe, but some of you might have already come across it also. Say, for example, this is the real question of the conditional probability. Okay, and then the probability just come close to what you call as chain rule. So if you just bring up this denominator up, then you find the probability of given B. So it's a multiplication of probability A. Probability of A and B is nothing but the probability of product of probability of A given B and probability of B. This is the formula which we can apply in the conditional probability. So say, for example, if you have the word A, B, C, D, or otherwise W1, W2, W3, or WA4. So this is how you're going to implement it. This is another mathematical formula or mathematical approach which we can implement. Let's see how it has been implemented. The formula is the V, or otherwise the big loss is a formula. Or otherwise the phrase you're going to okay. So the big loss is then you need to come up with the probability of this. And if suppose if it tends towards 1, then the sentence or the phrase is right. If it tends towards 0, then we can conclude like there is some error in this particular phrase. That is the concept. Now you may ask one question like how you're going to find the probability and how you're going to know the number of all these yes, of course. That is the talking point of what we call as corpus. Okay, corpus is another thing which we need to connect. For any knowledge, if you want to start with the work of NLP or computational linguistics, you need to have a huge corpus. That huge corpus, you need to find all this probability. So, for example, corpus is not the collection of data, but the what is the collection of data. Very important form. We need to account for this. Okay, so for example, for the text, paper corpus, or otherwise newspaper corpus. Say for English, you have BVC corpus, weighted corpus, all these things. Okay, for the new language, you need to create of your own. You need to collect some in terms of millions and billions of words all together in the sentence form or whatever way you want. So when you have a corpus of say for example 3 lakh word, okay, or otherwise 3 lakh sentences, okay, in that sentence you will be able to find what is the probability of the, you will be able to find what is the probability of the big, you'll be able to find the probability of the rate, you may be able to find the probability of the big red dot, and of course another one is the big red dot was. This can be, I mean, calculated, or this can be calculated or count from that very particular corpus. So larger the corpus, it will consume time, but still the possibility of reality or correct answer, I mean the having higher chances of having perfect answer is there when you have a huge corpus. So corpus collection is a must for those who just want to start working on any of the new language. That is one thing. So that is one thing. Now this is another example where you how to estimate like it it's something like this. You can read like this: the probability of this, okay, followed by this particular word the. Okay, so it was in its water is so transparent that the is the probability. Okay, in order to find that, I have already shown you how you're going to find it. So this is another position how you make it out. So the probability of having all of the whole phrase with the previous phrase, I mean the division of it will give you the probability of that. So that is one way how you can start the implementation of that natural language in the machine. So someone has to write a program for this approach so that the machine can understand. The linguist has to verify whether the output is right or wrong. That is the concept. Or otherwise, one has to know both the thing, the language, and the computation. Okay, so that is the beginning part of it. Now, if you look at all these things, I mean, to brief up with what I have been discussing, we can start talking about NLP. Before that, you can start talking about the input or input data or something where you'll have maybe automatic speech recognition or maybe text to speech sort of thing, or maybe only the text also is there. So these are the things which you need to know. Then you can start talking about the NLP, the basic NLP, where you can start talking about all this tool of NLP, and then you can start talking about natural language understanding, where the real implementation starts. Say, for example, it may be question answering, it may be sentiment analysis, it may be summarization. These are the real implementation of what we have designed in the NLP. So this is the process of what you can do when you start talking about the computational linguistics. Now, there are certain approach, technique, for the computational analysis of natural language. Maybe it can start with the rule base, then move on to discuss the statistical methods, statistical methods, uh, the probabilistic models. Okay, probabilistic models. Okay, so this is one thing. And then the advanced very advanced method. So, so, say the rule base. The linguistically motivated rules or usually rules will manually are to be implemented, and then some sort of knowledge driven taggers will be implemented. For example, in the POS tagging of this sentence, one may look into the sentence and started putting all the part of speech manually, or otherwise based on the concept of linguistic rules you can start putting all these things like secretary should be a noun, like beaver, it should be all these things, right? Because these are the take which you can implement it, because there are certain standard take which you can just implement it. So rule based is one of the basic implementation of the language. And maybe like say for example, I'm citing one example of a Manipuri rule based framework, where what happened here is we trying to just remove all the small suffixes, suffixes for the morphemes. Okay, morphemes. We are trying to remove the morphemes one by one. If you, so the word is like pushing hanjaram gadavni dako. So like if you remove all the morphemes one by one, this is a suffix, and then if you remove all these things, you will be able to find the last root word or ku. So this is one example of rule-based stemmer, where you can even design your own stemmer for your own language. So based on the rules, because in English also we have a very famous stemming rule called Potter stemmer. Where in this Potter stemmer, what happened is much of the English word can just bring to the root word with the rule which he has designed, which Potter has designed. You can just check it out in the net how this Potter stemmer is designed and how this rule is being set up by the Potter. Now, in the statistical model, you will have the n-gram model. This is another one simple example of a statistical model, because we have learned about the probability. Now we are trying to find the probability of some simple sentences in order to find out how it really works. Okay, so n-gram means n can be anything. It can be one, it can be two, it can be three. So n. So how gram, I mean, it's something that between two, between three more, between four more. If suppose if we are really implementing on natural language processing, this n represents the value. When you have a gram, means like you're going to make a comparison with all the values which we have committed. Say for example, if I take one, which it will come as unigram. If you take two, then it will become as bigram. If you take is three, then it will become as a trigram. If you pick up four, it will become as a quadram. Okay, so how it is really working. So this is the example. This is the formula. So if we have n number of words, probability of 1 to or W2, something like that, WN. Okay, of that, you're going to pick up only one word. Okay, and then it's a summation of all the probability of each word. If suppose if you're picking it as bigram, then you are going to pick up the word which is, which is having a following word called WK. WK1 is the previous word. WK is the, is the present word. So you need to find out the present word followed by the previous word. That is what is bigram tells about. If you talk about diagram, you have to find out the previous two words followed by this particular word. So there is another probability, and you are considering three words at a time in the diagram. You're considering two words at a time for the bigram. You're considering one word at a time for the unigram. If you consider about quadgram, you're going to consider four word at a time for finding the word. Now, say for example, the simple example here again is the man from Jupiter. Okay, if you talk about the man from Jupiter, and if I apply unigram, you're going to find the probability of the man, the probability of the, which has to be multiplied, probability of man probability of from the probability of Jupiter. Because we don't know we have a huge corpus, right? That huge corpus, we have to find the probability of the. Okay, because if you talk about 3 lakh word sentence corpus, the probability of the will be very high, and the probability of main will also be very high. The probability of from will also be very high. Maybe the probability of Jupiter may be little less, but still you will be having lot of thing in the probability. Okay, so that is the concept of getting to the probability. Okay, now if you talk about the bigram, so here I am considering two word at a time. I am mentioning one S because if you divide the main from, if I, okay, let's remove all this quotation and all. If I write Jupiter, okay, suppose this is then you need to find the lowest word. So in order to find the lowest word, we just try to put one thing in here on this. Okay, that is the reason why I have to. So starting with followed by this one. Okay, so you have to find the probability of the in the starting sentence. And same for the Jupiter also. You'll have to have a delimiter called S. Okay, because S, I mean, maybe at the end of the thing, you have to find out like what is the last word. So like that. So you have to find all the probability of two word for the bigram. You have to find probability of three word for the trigram. I'm putting 1, 2 as well because I don't have any word, so I'm inserting 2 delimiter here, 2 F's here. So that is the reason why I'm putting here, which means this is the starting word. So the being the starting word, what is the probability? You have to find it out. So looking at all those probability, you will be able to come to a conclusion like how you can decide whether the part of the sentence or the part of the word is right or wrong. So that's 9,222 sentences. Of that, I'm trying to get one simple sentence called I want to eat Chinese food lunch Spain. Okay, okay. So this is, suppose if I'm writing like this. So what I'm trying to create a matrix of it. What is here is like I'm trying to find the occurrence of frequency of I in the sentence 9,222 sentences. The probability getting of I is very low because there is low chance that in the corpus continuation in the probability. Is the reason, I mean, the frequency, I should say the frequency first. So I1, the frequency will be very high. I2, the English, the sentence structure is very wrong. That's the reason I couldn't find any, I mean, following word to with the word I2 is not found in that particular 9,222 sentences. What about I eat? Sometimes in that 9,222 sentence, I found 9 times I eat. I Chinese is not found. I food is not found. I lunch is not found. I Spain is found 2 times. What about one I? One I found 0. One is 0. 1, 2 is 0. If you calculate the frequency of all these things, you will be coming to something which is a combination of 2 words. So that was the frequency. Now converting it things like 0.002 is the probability is too low. What about 0.003? It tends towards 1 because the maximum point should be 1. It tends toward 1. So I1 is a very right word. I2 is very wrong. But again here 1, 2 is very right. 1, 2 because the probability.
Sorry to interrupt you. So
yes, sir.
you have only 6 minutes.
to talk.
6 minutes.
No matter, we can give you 8 minutes. No matter.
Okay. Okay. So this is the way how we can just find come up to conclusion about those things. This is the thing. I want to eat Chinese food and all this. So this is how you can just come up with a diagram. Now, another drawback here, if you keep increasing the number of the A gram N, unigram will give you comparison of only 10,000 when you have 10,000 votes. Bigram just keep on to the higher gram because when you're looking for good answer, so this one just give it this one. Okay. 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 So there is another is there because you don't really need some features like characteristics in order to identify or in order to just come up to the objective. We need to characterize. We need to identify some of the characteristics in order to come to the objective of it. Okay, so now, and here is another one, another technical support vector machine where you will try to draw maximum line classifying two classes. Maybe this may be the verb, this may be the noun. Okay, we'll try to find a line equation of a line which will just separate the two classes up to the maximum. So like we'll try to just draw like whether it will be the line should be like this, the line should be like this. But there will be a maximum. The base is to be carved out so that the two classes is being classified. So that is one implementation where you can just make it. And SDM, we have name entity recognition is being applied where name entity recognition is important because when you try to go for the machine translation, you need to know which words are the real nouns. Okay, real name. Sometimes ambiguity may pick up. Say, for example, the simple example is Washington. Washington can be the name of the place, maybe the president of US. Those are the things which you need to know. And moving on to the advanced technique, you have the artificial neural network. I think these are a little bit technical, deep learning and all. In order to make it more interesting, just give a glimpse of what we can really have, let me go to another point. Okay, another point where we can just.
Dr. Kishorjit, we have some limited time.
Yeah,
so
yeah.
we have to run out within 2 minutes. Yeah.
Okay, sir. I'll just come make it to the conclusion. Okay, fine then. I was thinking of explaining little concept of AI. Maybe
we'll invite you more.
Yeah. Fine. I'll just make it. I will leave this part. And anyway, I'll just come to the conclusion now, because so what we are at the point. At this point, what we really want is. What about talking to the future? That is the real motive. So as of now, people used to do the programming. So no, this is not the thing which we want in the future. Everyone, which will be very soon for the programming. That is the concept. Where you just copy the language, the program will be automatically being programmed by the machine. That is the real future. That is the real thing we want in the future. So ultimately, where you can start is you can start creating your own tools. Okay, maybe you are taking chunking, parsing, any whatever it be. Go to the machine translation where you will be able to translate one language to another. In that, you may require sometimes the speech recognition where you will be speaking in your own language, and then with the machine translation, you will try to have a concept of AI. This AI will pick up the natural language, which will automatically convert it into program, which this because the machine understands program. Machine understands program. Once this machine understands the program, the machine will automatically respond accordingly to what we have spoken. Another example is what asking is done. Okay, use talking with your own voice, but Google they definitely have to because it's happening everywhere and everyone is having that app also. In the mobile app, you press the button, voice, or otherwise you ask any question. There is another example, or this may be another turning point of the real implementation of what you call as the future. Okay, so let me conclude it here. So need to have a very strong mathematical logics if you really want to work in what you call as computational linguistic or maybe NLP, and you need to we need to design new advanced algorithm because day to day, I mean, every day we are coming up with different algorithms. Like you have deep learning, data science, then we're starting from all those classical models. As of now, you have data science also, deep learning, RNN, all these things. Then another thing is like the machine will start, I mean, having a self-learning sort of thing. You won't be able, you don't need to teach, but this machine will start learning of its own. Maybe there are some disadvantages on it also because when the machine starts learning itself, he will try to say, or the machine will start designing the machine again, another machine, duplicated machine, which may be very harmful to us or maybe very helpful to us. It depends on us. Okay, so at the end, we need to know is we need to bridge the gap between language and computing if we want to advance the future technology. That is the point. I should say thank you because I was thinking of explaining a little bit more, but maybe I don't have much time. Maybe next time on the topic also. Anyway, thank you. And if any one of you have any question, you can just ask me.
Wonderful and insightful discussion of the rules of language computation. Actually, you don't have much time, so you please have your email ID. Okay, you will write your email ID. Our students and scholars they will send email.
Yeah,
If
sure, sure.
they have any kind of question, discussion, any kind of understanding from you, they will mail you. And I now we have time to give you a lot of time to the speaker and all our audiences. Now, just I request of our Dr. Navi to give a time to the audience and the speaker. Please.
Thank you very much to our speaker, Dr. Kishorjit, for your very heavy and very informative talk on language computation. We would love to hear you again, and we hope to invite you in another talk series on computation linguistics, or it could be a certificate course, a short-term certificate course that we are proposing when the new semester will be admitted. We're proposing that, so let's hope that we can invite you by the time, and I hope that the participants have learned something new today. So please mail to our speaker for your queries and to get your response. You can also mail it to us. I have given the email IDs in the chat box. And thank you very much, Dhiren sir, for wonderfully moderating the session today. thank you to all the participants. Thank you. See you next week.
Thank you.
Thank you. See you.
See you.